All right, so there's a lot to unpack on this slide. Don't sweat. We'll go through it slowly. We're going to be talking about inverse functions. Inverse functions essentially we are just switching x and y. Switching x and y. Okay? So we are essentially interchanging the domain and range. That's an inverse relation, okay? X comma y becomes y comma x. Good. This is saying if f of g of x equals g of f of x equals x, then f and g are inverses. Okay, this is just a test for inverse functions, which we will practice. Inverse relations may be functions, so they're not necessarily functions, but we can do a test to see if they are functions. Okay, if the inverse of a function is still a function, then the original, so if the inverse is still a function, then the original is a one-to-one function. A one-to-one function means that every element in the domain has one element in the range, and vice versa. So every element in the range has one element in the domain. So the definition of a function is it just has to pass the vertical line test, but if it's one-to-one, it passes the vertical and horizontal line test to be a one-to-one function. Okay. All right, this is the inverse notation symbol, f inverse of x. So this is not f to the power of -1 of x. This is f inverse. They're different. Same. It's like it looks identical, but this is f inverse. F inverse. And inverse functions are reflected over the line y equals x, which you might recall looks like this. This is the line y equals x, so they're reflected over this. They would be symmetric over this line. To find the inverse of a function, so if we're given equations, what we would do is we would switch the x and the y values and solve for the new y, and that would be f inverse. So since we're just switching the domain and the range, the domain of f of x is equal to the range of f inverse, and the range of f of x is equal to the domain of f inverse. Okay, we're just switching the domain and the range. Okay, so here they're asking us to find the inverse of f of x and state the domain and range of f of x and the inverse. So if we were to find the inverse of f of x, so that's f inverse, well, we just learned that inverse functions just switch x and y. So here we would just switch x and y. So the point 4, 2 would become the point 2, 4. The point 3, 7 would become 7, 3, and etc. 2, 1, and 0, 5. Okay, and this is a set, and it's curly braces. It's a set. So the domain would just be 2, 7, 0, because we don't have to repeat 2. And the range is just going to be 4, 3, 1, 5. Okay. Oh, that's the domain and range of the inverse. I think they want us to also find for the regular function, which I'll leave up to you. I think it's self-explanatory. Find the inverses of each below. I really enjoy finding the inverse. Basically, step 1, we switch x and y. So that's the first step. So remember, f of x is, of course, just a very fancy way of saying y. So if we are to switch x and y, this would become x equals -4 over 5 y plus 7. So we switch x and y, and step 2 is solve for y. So we are going to isolate y So let's get that y by itself. Subtract 7 on both sides. We are left with x minus 7 equals negative 4 over 5 y. Two options here. You could, of course, divide both sides by negative 4 over 5, or you could multiply both sides by negative 5 over 4, which would also cancel that guy out. And then we're going to do the same thing over here, multiplying by negative 5 over 4. Okay, so now we have y alone. So we have y equals negative 5 over 4x. Boom, boom. And two negatives are going to make a positive, so we have plus. I remember when we're multiplying fractions, you could put this over 1. So negative 5 times negative 7, that's plus 35 over 4. And this would be our final answer. However, for an extra little step, which we really don't have to do, but I think is helpful, change that y. No, we should do this. We should definitely do this. To f inverse. If you put this, I would give you full credit, but really it should be f inverse is negative 5 over 4x plus 35 over 4. So f inverse of x is this. So then our last step, step 3, is you switch y, or replace y to f inverse of x. Okay, I get what you mean if you say y, but really it's f inverse. Okay. Okay, so same thing. This is y equals, but we want to switch x and y, so this is going to become x equals y squared plus 6. Okay, so now we have x minus 6 equals y squared. To get y alone, let's square root both sides, but do not forget your very important plus minus. So we get y equals plus minus square root of x minus 6. And last step, we should replace y with f inverse. Okay. Switching x and y, we got x equals y cubed minus 4. Solving for y, we have x plus 4 equals y cubed. And the last step to get y alone is we would need to take the cube root of both sides. So that leaves us with y equals the cube root of x plus 4. And remember, with odd roots, we don't need to add the plus or minus symbol, so don't worry about that. And here we are replacing our y with f inverse is the cube root of x plus 4. Okay. Boom. Okay, let's find the inverse of this guy. So we're switching x and y. So this is going to become x equals y minus 3 over 2 minus y. Now we have a number equals a fraction. So anytime you see this, the easiest way I think to do this is just to put x over 1 and cross multiply. Can move this up a little bit if it's ugly. Okay, and now we can just cross multiply these. We have x times 2 minus y, and we have y minus 3 times 1. So that's going to leave us with 2x minus xy equals y minus 3. So remember, our goal is to solve y. So we need to get the y's on the same side of the equation together. So we are going to either subtract y over or add xy over. Doesn't really matter. I'm just going to add xy over, then everything's positive, which is a little bit easier, I think. So those would cancel. So we would have 2x equals y plus xy minus 3. And the last thing is we want to move this guy over to isolate the y's on one side. So now we have 2x plus 3 equals y plus xy. And we want to get y alone. So first let's factor out a y here. So if we factor out a y, we have y times 1 plus x equals our 2x plus 3. And we want to get y alone, so we would divide both sides by 1 plus x. Cancel that guy out, and we would get our y equals 2x plus 3 over 1 plus x. And our last step is just replacing f with f inverse 2x plus 3 over 1 plus x. Boom. Final answer. Looks good.